In this lesson, we'll discuss physical and chemical changes. The question reads, is each change physical or chemical? Also, what kind of property, chemical or physical, is demonstrated in each case? Let's start with A. In A, we have the evaporation of rubbing alcohol. If rubbing alcohol evaporates, it's going from one state to another. It's not undergoing a chemical change. When you apply rubbing alcohol to a surface, it's a liquid. And then, after a little while, it goes away. It doesn't disappear, it just changes state from liquid to gas. That is a physical change, not a chemical change, because it's not reacting with a chemical. So for A, it's physical. For B, we have the burning of lamp oil. In order for lamp oil to burn, you need a mixture of oxygen and a starting heat source. Therefore, in order for fuel to burn, it needs to mix with oxygen, and when it mixes with oxygen and burns, it produces a brand new chemical. So this is referred to as a chemical change. For C, they ask us the bleaching of hair with hydrogen peroxide. Hair is made up of dead cells and proteins. When you bleach hair with hydrogen peroxide, it changes that hair color to off-white or gray. There's a chemical reaction happening between that hydrogen peroxide and the hair. Therefore, this is a chemical change. In part D, the forming of frost on a cold night. In order for frost to form, you have water molecules that are floating in the air that will condense to form snow or frost. The frost is not any different than the chemicals that are floating in the air, the water molecules that are floating in the air. So this is just a physical change. It's a state change from gas, liquid to solid. So we'll write down physical. Let's do this again, but this time I want you to slow it down and try to figure these ones out on your own. Let's start with A. A copper wire is hammered flat. Copper is a metal, and if you take a hammer to a piece of metal and flatten it out, you're not changing the composition of that metal. All you're doing is changing its shape. This shape change, without any sort of chemical change, is referred to as a physical change. A nickel dissolves in acid to form blue-green solution. If nickel is dissolving and it's changing to a brand new color, blue-green, the fact that there are brand new pigments in the solution suggests that a chemical change has occurred, especially if you are submerging metal with acid. There's usually a chemical reaction that occurs. So right away, we know that this is chemical. In part C, dry ice sublimes, and sublime means changes into a gas without melting. So it goes from being a solid, skips the liquid phase, and becomes a gas. Or arguably, you can say that the liquid phase is so quick that you can't even see it, just changes into a gas. This is a change in state. There's no chemical reaction happening, so this is physical. And in our last example, a match ignites when struck on a flint. If a match ignites, and a match is made up of a piece of wood and some fuel at the very tip, if enough heat is exerted on that tip, then it starts to burn. Burning requires oxygen. It's a chemical reaction. Therefore, this is a chemical reaction. And so there you have it. 8 examples on how to tell the difference between a physical and chemical change.